Welcome to Packet Pilots. In today's session, we will show you how to configure 802.3 AD link aggregation with and without LACP. In the lab, we have router 1 and router 2 connected with 2 links and then also some test PCs connected on port GE1. As you can see, we have a point-to-point working at the moment over a standalone interface GE0. The very first step is to enable the chassis for link aggregation. To do this, go to Edit Chassis and apply the command set aggregated devices Ethernet device count X. X in this case would be the total amount of AE interfaces you might require. Now go to Interfaces stanza and set the Giga Options 802.3A0 command directly under the interface. There should be no other logical units configured. Now go configure your AEX, or in this example AE0 interface, the same as you would configure a standalone physical interface. LACP is not enabled by default on AE interfaces and also not mandatory, however it is best practice to enable it where possible. Side note, with Junos you cannot bundle interfaces with different speeds, but you can bundle, for example, a 1 gig fiber port with a 1 gig copper port, but you cannot mix 1 gig with 10 gig etc. Also note that when you enable bundling, a new MAC will be created for the AE link. With an AE interface already configured on router 1, we will do the same on router 2. At this point we only have one child link specified. Now we will add port GE2 to the AE0 bundle. Here you can see the BGP session across this child link. Now I am sending a ping from test PC1 to PC2. Notice that we only see the reply and not the request packet. We can see on the GE2P cap that the request is going over that link. Now I will disable the GE0 link. You can see now both directions of the ping is now going over this link. We have recovered GE0 on router 2, and the flow is back as before. Now we will enable LACP on this link. With the LACP state in distribution, it indicates proper operation between both devices. You can also see in the PCAP file that LACP data units are sent across the links now. Devices use LACP to identify compatible ports at both ends of the connection. Each device sends out LACP PDUs, which carry details about the link's capabilities and current state. If a link fails or is added, LACP adjusts the link aggregation group dynamically, ensuring continuous connectivity without manual intervention. The detached state refers to a condition where a link is not actively participating in a link aggregation group or LAG. This state indicates that the link is not currently bonded with other links in the group to form a single logical connection. The router looks at the packet headers in outbound traffic, applies the hash, and selects the link in the lag to send the packet out. This ensures that the outbound traffic is spread across multiple links to maximize throughput. Inbound load balancing depends heavily on the behavior of the connected device. The device on the other end of the lag must apply a similar hash algorithm to ensure that incoming traffic is balanced across its side of the lag. Many lag configurations rely on egress load balancing at each end, so inbound load balancing is indirectly achieved by the sending device's egress selection. That is the end of this session. We will do another LACP deep dive session some other time. Thanks for listening, and I hope you learned something today. Cheerio!